Okay, welcome back everybody. So this is going to be the first video in the WPF, or really, I'm calling it WPF, but it's really desktop development for C#. So I'm going to talk a little bit about kind of the overview information that I put on Canvas first. So when I say WPF, what I'm talking about is a very specific kind of thick client UI framework that Microsoft came out with many moons ago. And so one of the main sort of ideas around C# is that it's always tried to be very user-friendly in terms of UI development, and most of the .NET languages are the exact same way. So if you think all the way maybe 15 years ago, you had drag and drop UI builders for VB.NET, so on and so forth. So what WPF is this kind of framework for building thick clients that let you build WYSIWYG stuff, but you could also use a markup language that's based on XML called XAML. And so while thick clients are largely dying, they're kind of falling out of favor in favor of web applications and service-oriented applications. It's interesting that XAML is kind of the cornerstone of most WPF, and it's also heavily used in Xamarin. So one of the reasons why I've added this module to the class, so this is all kind of new content, is because I wanted to add Xamarin, and this is in some ways a much easier sort of introduction to it than just jumping right in and talking about cross-platform mobile development. So the long and short of this kind of overview that I posted to Canvas is that WPF is interesting. It's interesting largely because of the combination of XAML and C#. You're going to see that again in Xamarin. It's interesting in that a lot of applications have been built on WPF, and there are jobs where you could go in and contribute to WPF applications and solve bugs and do maintenance. Largely, WPF is not really used for sort of new development, new applications going forward. So it's good legacy exposure to what C# UI development used to look like, and in the next couple of weeks, as we start moving into multi-tiered full-stack development, it's going to become very obvious why maybe this is kind of the older way of doing things compared to something like HTML5, and allowing C# to really be on the server side of things instead of the client side. So one thing that I do want to mention is there are all of these architectural concepts around how best to build client apps, and we're going to talk about that in a lot of detail in the next two or three modules. But what I want to do is give you some examples this week of kind of a very rudimentary code behind approach to building a desktop application, as well as a more I will refer to it, for lack of a better term, a highbrow approach to desktop development called MVVM, which stands for Model View View Model. And so this first code along video we're going to do is sort of the stock standard, very straightforward code behind way of doing things. And then in the next video, we're going to build a more complicated application. And in doing so, we're going to introduce MVVM. So key takeaways from this module. 1, WPF is kind of the legacy way of building UI for C#. It's great for thick clients. It's great for enterprise level software companies that want to build thick clients. It is being largely replaced by multi-tiered sort of web applications, and web applications are really shifting towards something like Xamarin on the mobile side, or like HTML5 for the full sort of desktop experience. It is important, A, because of Xamarin, but also B, because it gives you a sort of very easy to understand introduction to Model View View Model, which is one of the patterns that we'll end up talking about when we talk about sort of client side or desktop side computing during the multi-tiered modules. So enough babbling. What we're going to do is we're going to talk about how to build a stopwatch with WPF as a sort of thick client. So let's get really concrete about what I mean by a thick client. What I mean is this is an application that will run solely on your machine. It does not have access to or need access to the internet. And basically it is a glorified console application that has a UI instead of just interacting with the console. And that's purely it. It is called a thick client because we will see thin clients, which are actually just UI, and all of the sort of business logic and all that stuff is shifted to a server somewhere. So the thickness of a client is really related to the resources that are required to run it effectively. So how much computing you're actually doing on the client side, how much business logic you're running, and all that kind of stuff. So here, these applications are going to require a lot more local resources than a thin client, and that's something that we're going to spend about 3 weeks talking about starting next week. So this is a mock-up of exactly what the stopwatch will look like. And so if I run this thing, come over here, and so I can start it, I can stop it, I can start it again, I can stop it, I can reset it. So if you are able to, you can download this whole solution from Canvas and kind of follow along. And so the first thing that I would do is make sure that you can actually run the application. So one of the things in the Canvas overview that I didn't mention is that this module will have an assignment at the end of it, but that assignment is optional. And the reason it is optional is because WPF proper really only runs on a Windows machine. So if you are one of the approximately 30% of the class that doesn't have access to a Windows machine, you only run Mac, you can choose to punt on this assignment. You can watch the videos, you can follow along, get your feet wet with the XAML, like this sort of syntax. And then in the Xamarin module, there will be a follow-up optional programming assignment that you can do that will let you perform that programming assignment on a Mac or iOS machine. And so you don't necessarily have to worry about building like a Docker container or building a VM unless you truly want to, and that's entirely up to you. So I'll post a little bit more information about the optional assignment and what it kind of means. It's for practice more than anything. So just be aware. If you have a Mac, you're going to have a really hard time trying to run the sample code that's posted on Canvas. If you're running a PC, you should probably run and download it really quick so that you can kind of walk through it with me. So this is what it looks like. Great. That kind of gives you an idea. This is what the solution looks like. So over here, you have exactly the same kind of setup that you had with a console application, except here we have these two files, which are actually all of the files that we need for the application. So this first one, the .xaml file, is exactly this. So it is possible to go to this toolbox, and after it finds all of its tools, it initializes, you will find buttons and text boxes and text areas and all that kind of stuff, and you can drag and drop them onto you can drag and drop them onto this painter and get the WYSIWYG experience that has been around since maybe 2008 or 2007. So that's certainly one way of living your life. You drag and drop stuff like buttons, and so you could say a common, so a border or a button or a stack panel or whatever. As you drop things onto the canvas over here, what will happen is this stuff down here, this code, will actually start getting generated. So this code, once you get kind of familiar with XAML and more comfortable with it, this code is definitely the way to go. And the reason is because if you look here, I actually have a grid and a stack panel and I have a text box and buttons nested inside of the stack panel and inside of the grid. If I did not have those things, what would happen is when I resize this window, these would not move. So you have the situation where the user can move the sides of your window and just arrive at these sort of hilarious looking versions of your UI that aren't necessarily flattering. So you get kind of issues where even when you run this thing outside of a grid and a stack panel to align everything, it will start deviating. So for example, the edges won't all line up, or the spacing between things will be different than it looks like on this screen. So to be clear, this is basically an approximation of what this code is actually doing, because if you drag and drop over here, you're actually really relying on resolution to get you in the correct position of the parent control here. So you can certainly drag and drop. I prefer to actually just type the code out. It's very similar to HTML, and we're going to go through some of the high points now. So this whole part up here, this is identical to the C# using statements. So all of these things are namespaces, and these namespaces right here are basically standards that you can use to gain access to the sort of standard WPF toolkit. So if you wanted to build your own controls or whatever, you could put them inside of the namespace for your application, and you would be able to use those by saying local dot blah, whatever the name of your control is. That's a little bit outside of the scope of the things that we want to do. Most of the time, if you're trying to do something fairly mundane, all of the sort of out-of-the-box controls are sufficient for what you want to do. So this part is really just management stuff. It's kind of boilerplate. Almost all of this stuff gets generated for you. And if you find yourself adding things up here, you're probably doing more advanced things than we're doing right now. So inside of that, we have the window tag. And so all of this is header information. And so within that window, you can start nesting any tags you want. And so this mirrors exactly HTML. This is basically just a souped up version of XML. So we have a grid. The idea of a grid is that a grid can have columns and rows, and we're actually going to see that in the next application. It uses the grid much more than this one actually does. The reason we have a grid here is just to give us effectively a blank container. So we're using grid here kind of as a div in HTML, for lack of a better analogy there. So what Stack Panel does, Stack Panel gives you another sort of container type control. But what happens is as you add things to the Stack Panel, they render on the screen. And so here we have a text box. That text box is ultimately going to show me the time up here. We have 3 buttons, one for starting, one for stopping, and one for restarting. We have margin. This margin works exactly the same way as HTML5 does. We have things like is enabled for text boxes. They work exactly the way that you would expect them to work. You have a name property. So we're going to talk about that in just a second when we go to the code behind. Typically, best practices in WPF design is that you should not have names, but I had that there just to show you that you can actually provide logical names for controls in case you need to modify the controls in the code behind. That's totally a thing that you can do. So this text property is the actual text that's going to render inside of the text box. This content is exactly what's going to be shown in the button. And so you can see that each of these controls has slightly different terminology around the properties and what the properties do. As you are probably aware of now, the C# language and in fact WPF itself is very, very, very well documented. So if you look up text box WPF, it will list all of these properties and all of the values that those properties can take on. Most of them are fairly straightforward. I have things like font size, things like horizontal alignment, and so on and so forth. The elephant in the room is this bit right here. So this is the ridiculous binding syntax for binding data in the code behind to the control on the front end. And this is single-handedly the most frustrating thing that I have done perhaps in the last 20 years of doing computer science sort of stuff. This we're going to talk about after we look at the code behind them. So the rest of this should be kind of straightforward. Let's go to the code behind and take a look at that. So the code behind is just C#. It's exactly the stuff that we've been doing for the last two sort of console applications. And so what I want to do is I want to look at the fields, I want to look at the properties and the constructor first. So here what we have is a main window. This class is called the code behind of the window because it is basically the code that is behind the window. This is a class that is automatically generated when you create a window XAML file. There's an accompanying .cs file. This thing is essentially automatically bound to that UI. We will talk about these in a little bit of depth in a moment, but window basically gives you the ability to call the close function and sort of manage the resource. We talked about managed and unmanaged resources a little bit before, and basically you can get into situations where you have dialog boxes that are popped up from this main window or any other windows, and you have to ensure that you're calling the .close on the window because the .close implements the disposable properties of the window within that method. So we want to make sure that we have all the functionality of the base window class on our windows, otherwise we're going to be stuck with windows kind of hanging around doing nothing. This one is more complicated, and we'll get to that in just a second. So here we have two fields. The reason these things are fields is because A, they're private, and B, I don't actually need any business logic to be run on them. They are strictly data. They don't pose any other features. So notice they are private, which means that no other class can actually modify them to begin with. So it isn't a huge deal that they're just fields and not properties because we are really in control of this class. The class is pretty small, so trying to scrub data and that kind of stuff is not really a high priority at this point. So I do have this field, which is out of place. So these are fields, and technically this is also a field. And what these things are doing is they are providing me access to data that lets me actually perform the business logic of the stopwatch. And so we'll quickly go through these things. This is just a stopwatch that functions like a stopwatch. This is in the diagnostics library or namespace because you usually use this to make sure that your service calls or something like that are abiding by appropriate timeouts. So you can also use it for telemetry to figure out what part of your code is taking the longest if you're experiencing performance issues and that kind of thing. This is different than a dispatch timer because dispatch timer actually exposes some events that are useful when actually trying to use a dispatch timer as a stopwatch. The problem with dispatch timer trying to use it as a stopwatch is it doesn't necessarily have the nicest sort of functionality around it. Stopwatch is easier to use. Dispatch timer has all of the events that we need in order to sort of make the UI work. Timespan is another class in C# that gives you access to a length of time that is broken into reasonable buckets of time. So we're going to use this to separate the amount of time that's elapsed into sort of hours, minutes, seconds, and milliseconds over here. So this is our first property. And in fact, this is the only property that we need because really the only thing that we're trying to do here is manage some buttons and then show one value. So this is a property that does not have a setter, it only has a getter, so I can't do time equals blah because this is effectively a read-only value. Notice that this also uses the string.format method, and what it's doing is it's taking the current time span, so the length of time that's elapsed, and it is using this format to actually render each of these buckets of time into the appropriate position in the string so that the string can be displayed on the UI. So that's this is really the part that we're going to talk about in terms of binding. Before we do that, though, we're going to talk about main Windows constructor. So in the constructor of anything that derives from window, you're going to find something akin to initialize component. What initialize component does is it sets up all of the memory requirements, it sets up all of the event handlers and all of the everything that you would possibly need for the main window to function as a window. So this is, again, boilerplate code that gets generated once you come over here and do add window. This will appear in the constructor of whatever you name the window. This bit is mysterious, and if you have never seen it before, this is the crux of all of the frustration that you will experience for WPF for potentially weeks until you figure out the correct question to ask Google, which is not a straightforward sort of question. So what this is doing is this is actually actively binding the data bucket associated with this form to this class. And so when I said before, this thing is bound, this class here is bound to the UI, what I meant is that this has access to all of the event handlers for button clicks, event handlers for double clicking, or for tabbing out of a text box, all that kind of stuff. It does not automatically bind to the properties or the fields or the methods or the whatever of the actual class implementation until you put this line. So the data context property of the window being bound to itself sets the bindings of each of these sort of things to the properties of the class itself, so that you can bind the data as well as these event handlers for clicks. So this, for whatever reason, does not get automatically generated when you create the window, largely because this is not the way you handle it in MVVM, and so in the second code along you'll kind of get a taste of that. But if you want to just do a really quick and dirty thick client application, this is the line of code that is missing, that is non-trivial to sort of Google your way to figuring out what it means. So in the rest of the constructor, it's pretty straightforward. What we're doing is we're setting up a new stopwatch. We expect that this constructor only gets called once the application runs for the first time. So we want to make sure that the stopwatch is set. We could just as easily set it up here. We could say new blah blah blah, and it would be exactly the same as this. I just put it in the constructor because I think it makes more sense. It consolidates everything. Same thing with dispatch timer. And then this part is our first exposure in C# to event handling. So I was talking before about the difference between dispatch timer and stopwatch. So what you would think is that stopwatch would expose an event that fires every time the stopwatch rolls to the next millisecond or the next jiffy or whatever, but it doesn't. Dispatch timer does though. So what happens is every machine tick, it actually sends a tick event that you can subscribe to. So this plus equals, what it's doing is it's adding this event handler to this event that's exposed by dispatch timer. So dispatch timer is part of the .NET framework. You don't have to really do anything to get it. It's just sort of there. And what you can do is you can subscribe your own event handler to that event using this plus equals syntax, and everybody is happy. If you want to remove that handler, you would do a minus equals, and that will remove the handler, and then ever after that line of code is fired, even if a tick event happens, this event handler will not handle that event. Okay, so what does this even mean? So there are lots of different kind of names for this, but basically these are called delegates, and what happens is you can provide the name of a function or the name of a method as an argument here to event handler, and what will happen is every time this tick happens, it will automatically forward the appropriate parameters to this function. So this is acting as a delegate for this. We'll go through delegate syntax a little bit toward the end of the class because it's kind of an interesting concept. It helps us with some more advanced kind of architectural stuff. But for right now, all you need to know is that you need a function that has the appropriate parameters. So in this case, a sender, that's an object, and an event args parameter. You can name it whatever you want. And as long as you have this method signature, you can add the name of that method to the parameter of an event handler, and that will automatically subscribe this event handler to this event. So every time a tick event is raised, this method will be called, and as long as the stopwatch is running, what we're doing is we are setting the current time span to whatever the elapsed time on the stopwatch is, and then we are notifying the UI that the property that is bound has changed. So this part is now the biggest mystery, and so we'll go back to the UI and sort of tie it all together. So what the heck does this actually mean? So we're going to take it one piece at a time. So this binding syntax means that I want to bind this property, so the text property of the text box, to this property on the data context. And so back here we said this is the data context. All right, cool. And we have a property named time, and I want to bind time to this text. And so if you see time is a string, and it's going to give us the formatted string that gives us what the elapsed amount of time on stopwatch is. This mode one way means that we are only going to bind from the source, which is this property is the source, to the target, which is this text box. It's got to be one way because this doesn't have a setter. And so it's actually physically impossible for someone to set the time in this specific stopwatch. So we can't have two-way binding. And so if you don't have mode one way, and if you remove this and try to run the application, it will fail, and it will say it's not possible to have a property, a bound property that doesn't have a setter. And so you could add a setter here, and that would run. You'd get weird behavior here unless you removed the is enabled here. You could actually change the string, but we don't have any code behind to actually update the current time from the string. So it's one way because we're only allowing the code to update this, not the user. Okay, so update source trigger. This is not actually required, and so you could actually remove this and everything would be fine, but what this means is that we want the source trigger to be updated when the property that's bound changes. So right now we just said we're not allowing people to change it here, but that's fine. I put it here just because I wanted to show what the syntax looks like. Here we have notify on source updated. This is the part that matters the most. So notify on source updated means that we are going to notify the target, which is this control, that it needs to re-render the contents of this property as soon as the source itself is updated. So when do I know when the source is updated? I know because I send this notify property changed event. So notify property changed is saying I am changing a property, and that property is named blah. So this is the name of the property that's being changed. Over here, when that event is raised, this control will be made aware that the binding that it is set to has changed, and so it needs to update the UI to the next time increment. The question is, where the heck does this thing come from? Because this is a method, and it is nowhere to be found. Oh, and it is to be found right here. But what we are doing is we are using this as a wrapper for the actual invocation of this property change thing that isn't actually on our class. So the question is, where does this thing come from? This thing comes from this iNotify property change. So because I have implemented this interface, I have access to this thing, and so I have the ability to actually raise this or raise this method, which invokes the property changed event, and then passes the name of the property to the UI, which then updates the binding. So without this right here, what would happen is when I run the application, I would hit start and nothing would happen. It would stay 0 zeros, and you would be able to set breakpoints and go into here, and you would see that the current time span would be running, but the UI would not update. And the reason is because it won't update until it's notified on source updated, and I can't tell the UI that the source is updated without raising this event. So that's kind of how all of that ties together. Let's talk about this bit. So this is strange new syntax that I somehow forgot that I added in here, but with good reason. So this right here is essentially a wrapper method, and we could have just as easily just used this syntax up here, or right here, and up here, instead of using our own method. What makes this easy is I don't actually have to put time in quotes in here, because what I've done is I've used this thing that will actually use what's called reflection to figure out what property has raised the event, and then we'll substitute its own name into this property here. So if I were raising that event from the actual properties getter or setter, then that would not require time to be in quotes. We would literally just call notify property change with no parameters. The reason is that this optional attribute here essentially instructs the compiler to substitute the blank property name for whatever the name of the property that calls it is. So this is a very concrete kind of new way of seeing the benefit of having a property. You can't bind things in WPF to fields, and you certainly can't use features like this on a field because it won't necessarily know what the name of the field is. So this bit and this bit should now be semi-clear. Basically all it's doing is it's raising an event every time we fire a method, and we're firing that method every time we are changing the state of the clock. So here what we're doing is we're saying it's changed the state because it's gone to the next millisecond, the next millisecond, and the next millisecond, and every time we're going to raise an event that tells the UI that we need to update and change this number over and over and over and over again. So we can stop. Cool. So that handles the actual display of the time. It also handles most of the code up here, so the fields and the properties and the constructors, and this is a method that is solely there for handling the event. The rest of these things here up are button click events. So these are also handlers, and you can see the parameters and the sort of prototypes of these methods are very, very similar, except here, instead of being bound to an event that is on a class in the code behind here, what we're doing is we're binding them to events that are raised by these controls. So if you look at the start button, for example, there is a click event here. And what I've done is I've specified the name of the method in the code behind that should be fired to handle every time that event is raised. So if we go through these really quick, start is going to start the stopwatch, and it's going to start the dispatch timer. That's it. If I stop it, what I'm going to do is I'm going to make sure that it's running first, and if it is running, I'm going to stop. If it is not running, I'm not going to do anything. When I reset, what I'm going to do is I'm going to reset the stopwatch. I'm going to reset the current time span, and then I'm going to notify the UI that the time span has changed, right? Because without this one, what's going to happen is you're going to hit reset, and the same time is going to be shown on the stopwatch until you start the next time. When you start, it's going to start counting from 0. So without this, it's a little bit of a jarring experience, and that's really it. So once we put that all together, again, we have a text box that is bound to a string property with only a getter. It only has a getter because we don't actually want to set it from the UI. What we want is it to be set on an event that is tied to the dispatch timer object. So we've created our own dispatch timer, and every time this thing ticks, we're going to update the current time span, and that current time span is used in the getter for the property this control is bound to display the time. When I hit the start button, that is going to go to the start click event handler, and that is going to fire stopwatch.start and dispatch timer.start. So it's going to start the actual underlying stopwatch, which is used to set the current time span, and it's also going to start the dispatch timer that is used to fire the .tick event, which tells us to update the UI every time the stopwatch ticks. If I hit stop, it's going to come in here and it's going to say, oh, previously I was running, now I'm going to stop the stopwatch. The dispatch timer continues to run in the background, and that's kind of okay. You could add a dispatch timer.stop in here if you want. It makes it a little bit jumpy when you go from start to stop to start to stop, and that's really the only thing. You don't actually really even notice it until you go to fractional milliseconds, but it is what it is. So stop is pretty straightforward. And then restart is going to reset the stopwatch, it's going to reset the time span, and it's going to update the UI back to this reset time span. So the default values of time span are all zeros, and it resets this UI element because we fire the notify property changed event. And so that is that. So this is a really straightforward application, but I think it kind of illustrates all the high points of WPF. Namely, this syntax. This is the most frustrating syntax that we might experience in the class. It's still going to be frustrating in the Xamarin module, so this is largely the reason why I wanted to add WPF as its own module, to kind of give you time to take a look at it and get comfortable. In the next video, we're actually going to build a support ticket tracking system, a kind of rudimentary one with a UI, and that will show you more of how grid alignment works, and we'll also go through how to pop up a dialog from a main window and close a dialog and manage the resources and all of that. So I hope you found this useful and kind of educational. If you have questions, comments, concerns, if you can't get the code to run, please let me know. I am happy to lend a hand. Thank you for your attention, and I will see you in the next video.